Welcome to Classwork 7.1, Textbook Section 5.2. Today we are going to study the sum and difference formulas in trigonometry. So take a moment just to write down what's in this 3D box. I'd recommend pausing the video and then unpausing when you're done, and make sure you take careful note of where I've put the plus and the minus. Now that you've written those down, we're going to make a couple extra notes here. The first thing to note is this right here represents 6 formulas. You must have these 6 formulas memorized. Hopefully you recall them from trig a little bit. The reason there are 6 formulas is because the plus and minus correspond. So for example, if I wanted cosine of alpha plus beta, that would mean cosine alpha, cosine beta. Notice how if it's plus, it corresponds with the minus, then sine alpha, sine beta. Now, to help you remember these formulas, a couple of things happen here. For sine, notice that the sign stays the same. For cosine, notice how the sign switches. And for tangent, it's a fraction. This part's pretty cool. The top stays, and the bottom will switch. And that's because tangent is sine over cosine. So that would make sense that it should stay on the top and switch on the bottom. Now let's try to do a couple formulas on this question here, or use the formulas. We have find the exact value of cosine 15. So 15 obviously is not on the circle in a clean way. The only ones we really know are multiples of 30, 45, 60, and the quadrantals. So we're going to use a formula to figure this out. We're going to do cosine of alpha minus beta. So we're going to use cosine of, think of 2 angles that subtract the 15. We could use 45 and 30, or 60, 45, doesn't really matter. I'll just do 60 and 45. Let's plug it in our formula. Cosine alpha, so cosine 60, cosine 45. The sign will switch, so plus sine 60, sine 45. And now we've figured these out. That's just 1/2 times root 2 over 2 plus root 3 over 2 times root 2 over 2. This is root 2 plus root 6, all divided by 4. And that is our answer. Done. Now for this next one, a lot of people look at example 2 and they think they have to do the sum and difference formula 4 times. 1, 2, 3, 4. Make sure you do not do that. These should be the easiest problems you get on a test quiz or on your homework. These are simply the reverse problems, meaning you just have to look at the formula and figure out which one is happening and then apply it in reverse. So I'm going to look at this, and I see cosine, cosine, sine, sine. So that looks like the cosine formula, cosine, cosine, sine, sine. So I'm going to put alpha and beta here. So this is cosine. Instead of alpha and beta, let's write 80 and 20. Now we're wondering if it's plus or minus. Notice how it's plus here. And for cosine, the formula will switch, so this must be minus. That simplifies to cosine of 60, and cosine of 60 is 1/2. There is our answer. Done. Next example, verifying an identity. So for this one, we're going to pick the left side just because it looks like there is definitely more to work with because of that a minus b. So we're going to expand that. So cosine a minus b, that's cosine alpha, cosine beta. The sign should switch, so plus sine alpha, sine beta. Divide that by sine alpha, cosine beta. At this point, let's split the fraction. So it's cosine alpha, cosine beta, all over sine alpha cosine beta plus sine alpha sine beta, all divided by sine alpha cosine beta. Notice how this reduces. Cosine over sine is clearly cotangent, and sine over cosine is tangent. And there it is. We've proved it. Happy face. Last example. Find the exact value of tan 7 pi over 12. So we could use the difference formula, but I think adding two numbers to create 7 pi over 12 would be a little bit easier. So I recommend just putting over 12 and try to think of two numbers that make 7. So I'm going to use 3 pi and 4 pi. Now the reason I chose that is because that's going to reduce to pi over 4 plus pi over 3. I would put a note up here. A lot of people want to use like 6 pi over 12 and pi over 12 because they think 6 pi over 12, that's nice, that's pi over 2. The problem is this pi over 12. You can't figure that out in your circle. So that's why you don't want to use things like this. Or some people want to use like 5 pi over 12 plus 2 pi over 12. This 5 pi over 12 you can't really work with. So you got to pick two numbers that are easily reducible and you can work with them very quickly. So that's why I chose pi over 4 and pi over 3. So now let's apply the formula. That's tan pi over 4. On the top, the sign should stay. And then on the bottom, we're going to put 1. The sign switches, so minus tan pi over 4 times tan pi over 3. Now this is why you have to be good at your unit circle values. This is going to become 1 plus root 3 over 1 minus. That's just 1 times root 3, so we'll just make that root 3. And actually, we're going to leave the answer like that. This is fine. So make a note. Answer is fine. The only thing I don't want is you can't have complex fractions. So again, I'll make a note. No need to rationalize this. Now on your homework, the book will rationalize. To check your answer, just plug that in your HP prime. So for example, the book answer for this problem is going to be -2 minus root 3. To check if you're right, just plug into your calculator. So alright, plug in to HP to check. Sorry for all the arrows. That's it.